We've just passed the summer solstice point. For the northern half of the Earth, it was the longest day of the year. Above the Arctic Circle, the sun stayed over the horizon for 24 hours. The Earth's axis is tilted 23 degrees, and the Arctic Circle is 23 degrees from the pole, so it's just brushed by the sun. But below, at the Antarctic Circle, 23 degrees from the South Pole, the sun didn't rise at all this weekend. Even at noon, it stayed below the horizon. The days are shorter in New Zealand and the south of Argentina. The seasons are the other way around there. The sun's rays arrive at a low angle and supply less heat. It's winter. In 6 months, the Earth will be on the other side of its orbit. On the 21st of December, it will be the summer solstice in the southern hemisphere, tilted towards the sun. At noon, the sun will be directly over the 23rd parallel, south, above the Tropic of Capricorn. Why Capricorn? Because at that moment, the sun appears in front of the distant constellation of Capricorn. But for now, summer's beginning here, in the northern hemisphere. From the North Pole down to the Arctic Circle, on the day of the solstice, there's 24 hours of sun, no night. And in the northern regions, not too far from the Arctic Circle, the nights before and after the solstice are white nights. In St. Petersburg, Stockholm, Oslo, Copenhagen, Hamburg, Berlin, London, and Calgary. In this northern part of the globe, the sun sinks only a short way under the horizon. Its glow can still be seen gliding from west to north, then east. After the sun sets, a glimmer remains sliding slowly across the horizon. Towards midnight, this glow is in the north, and it moves towards the east where the sun rises at dawn. In a zone slightly further to the south, covering Paris, Winnipeg, and Vancouver, this white night glow can be seen until midnight, and it reappears at about 3 in the morning. A little further south, in Orléans, Zurich, and Montreal, the northern part of the Earth rises too high above the sun and blocks our view of its glow. At this latitude, there are no white nights. The light we see by, the light that keeps us alive, comes from the sun. Our eyes see it as white, but if we break it down, it holds all the colors of the rainbow. The light we see is only a small part of the rays the sun fires off into space. Beyond violet, the sun emits rays that our eyes can't see. These are ultraviolet rays, X-rays, which can go through certain things like your muscles and lungs with their very high frequency. Then gamma rays, given off from the hottest parts of the sun's surface. On the right, the spectrum of visible light ends with red. Beyond red, the sun gives off other rays which our eyes can't see. Infrared. Then comes microwaves, yes, the same ones you use to defrost frozen food, and low-frequency waves, like radio waves. To study the sun, we have to examine it outside the visible wavelengths. While the distant stars hide by sending us too little light, the sun dazzles us to conceal its secrets. But we can't complain. Our eyes are adjusted in the best possible way to see both at night and in the day on our Spaceship Earth. That's exactly what we need. Watch out. Never look at the sun without protecting your eyes. Sunglasses aren't enough. Neither is glass smoked over a candle. To look at the sun, get yourself a little solar filter. They're not expensive, or project the image of the sun through binoculars onto a sheet of white paper. You'll see sunspots. They're holes in the gas of the sun's surface where there have been eruptions. You can follow the sun's rotation by watching these sunspots from day to day. The spot that's here today will be there tomorrow. We can use sunspots as a guide to see how the sun rotates. But they also help us to see the sun in 3 dimensions. Neighboring sunspots move closer to each other when they reach the edge of the solar disk, because it's not really a disk, but an enormous ball of gas. As you follow a sunspot, you can also imagine the dimensions of our Earth-Moon system. The sun is so big that it could easily contain the Earth with the Moon orbiting around it. The Moon travels around the Earth in 4 weeks, like this sunspot, which shows the sun's rotation as it travels around, taking 4 weeks too. So the entire Earth-Moon system is no bigger than this star called the Sun. A rash of sunspots flares up every 11 years. The next high bring the greatest number of sunspots since they were discovered by Galileo 400 years ago. Sunspots also show us the Earth's movement. If you see this sunspot here in the morning, you'll find it here in the evening. But it's the Earth which is tilted during the day, not the sun. In the morning, the sun appears at this angle. The Earth turns and the sun seems to cross the sky during the day. In the evening, it appears at this angle. The sun hasn't moved, but we're looking at them from a different angle. Like this in the morning, like this in the evening. Every day, with or without sunspots, you can see the tilt of the Earth. At sunrise, the Earth turns towards the sun. In the evening, the Earth covers the sun.